My name is Mia Burke, and I am program manager with Hanford Challenge. Hanford Challenge is a nonprofit based in Seattle that focuses on a safe and effective cleanup of the Hanford nuclear site. And the most important thing we do, and one thing that makes us unique, is our support of workers on the front lines of cleanup. This is the 24th webinar of our Nuclear Waste Scholar Series. If you're new to the series, we started it to inspire action and involvement with Hanford Cleanup by inviting speakers to share groundbreaking scholarship, art, research, and experience working with nuclear waste. It is my pleasure to introduce our speaker today, Jim Werner. Jim has worked for more than 40 years as a field environmental engineer, a policy analyst in leadership positions for state and federal agencies, at Natural Resources Defense Council, as a consultant for states, DOE, and EPA, and on Capitol Hill for the U.S. Congressional Research Service. As director of the Strategic Planning and Analysis Office for the DOE Office of Environmental Management, Jim led efforts to publish Linking Legacies, Closing the Circle on the Splitting of the Atom, and From Cleanup to Stewardship, as well as the Baseline Environmental Management Report and Plutonium: The First 50 Years. At the U.S. Congressional Research Service, Jim was awarded a fellowship at the Library of Congress to study long-term stewardship issues, which he will be talking about today. Just as a heads up, the presentation will be a little longer than an hour long, and we will leave time after the presentation for Q&A. If you can't stick around for the whole time, feel free to leave. We will be recording the presentation, and we'll share a link of the recording with everyone that registered. Thank you so much for joining us today, Jim. I'll pass it to you to talk about long-term stewardship.
Thank you for that very gracious introduction, Mia. And I also want to just thank Hanford Challenge for hosting this Nuclear Waste Scholar Series. It's had so many good presentations, and I've had the opportunity to see several of them, including from my friends Tim Connor and Arjun Makajani. Also, thanks to the Hanford Challenge for all of the great work that's just, particularly the vital collaboration that's central to the work you do, collaborating with the Native American Indian tribes, with the workers, the United Association workers, and with state regulators, all of whom have an important role and important voices. And Hanford Challenge has done a great job of collaborating, and really it's an important independent watchdog that is sorely lacking these days with so many of the NGOs going out of business these days. And I particularly appreciate a new generation of people stepping up to be involved. I first met Tom Carpenter when he was working in Washington, and he obviously has built up an extraordinary group of younger people working on these issues at Hanford Challenge. So I appreciate the work you guys have done. But I didn't realize that Mia was going to do such an introduction. So, I'm going to skip past through a bunch of the slides, but let me just mention, when we talk about Hanford and protecting people with fences, it just reminded me when I looked at this that, aside from all the other things that Mia mentioned about my background, I kind of go back to a lesson I learned. I was born in Marcus Hook, Pennsylvania, which is, for people who don't know, an industrial refinery chemical plant area. And one of the fun things we did as kids was crawl underneath the fence at the cemetery, between the cemetery across the street and the hazardous waste site that was there. We called the acid pits. And basically, Mia said that I went to a bunch of college and grad school and had some experience. So we don't call them acid pits anymore. We call them RCRA regulated surface impoundments under 40 CFR 264 subpart K. But they're basically acid pits, and we crawled under the fence because, frankly, if there wasn't something interesting on the other side, why the heck would they put a fence around it? So, that was a very important lesson nowadays that I end up in these meetings where we have these serious discussions with lawyers and insurance companies and developers about instituting institutional controls to keep people safe from exposure at these waste sites. But frankly, that was one of the more important lessons I learned over it. But so I'll skip past a lot of the other experience I had. I think Mia, you mentioned you'd be able to make these slides available for people later on if they care to look at it. Some of the documents may be of useful use, and we can make those available since I know DOE has not put some of these up on their website. And we were able in the 90s when I worked at DOE in the Clinton administration to sponsor some good work by Resources for the Future. And I'll get to this in a few minutes, the rolling stewardship work about how to pass on the lessons and the information about residual contamination at the sites. Here's what I want to present today. There's 7 topics. Just by way of a little introduction, sometimes it's helpful to look backwards about where's the oldest nuclear waste. And spoiler alert, it's not Hanford. Um, the main kind of understanding that some of you may have, but it's important to kind of accept and recognize this, is that cleanup is not cleanup as they may be thought of in the vernacular. The norm is really remediation and long-term stewardship. Also, it's not just radioactive waste. There's a lot of different contamination and waste out there, and a lot of different institutions involved in it. And central to the presumption that anybody should be listening to this talk today is who cares about any of this? I hope I can make the case that it is important to care about it for a number of reasons, and to define more precisely what is meant by long-term stewardship in the talk today, and also just the communication, that the idea of we're going to have to figure out a way to pass this information on to future generations, and what are some options for doing that? And lastly, the options for legislators and regulators consider to tackle this in a realistic way somehow. So let's get on with it. The beast, of course, is the Hanford site that many of you are familiar with, and that's the tractor called the Beast that's used for moving the submarine reactor compartment you'll see in a minute. But I hope that that even though a lot of people are mostly focused on Hanford, associated with Hanford Challenge, there's a lot of other sites that share some very similar attributes that are a challenge. And people have often asked me after my experience, what's the most important hazardous waste site? What's the worst hazardous waste site? And I always say it's the one that's near you or the one that's near your family. So even though Hanford certainly has a central role in Washington, Eastern Washington, really throughout the country, and it's not necessarily the most important one to many people. And of course, as you know, a lot of people don't even know about Hanford. Hence the importance of the next generation of Hanford Challenge workers continuing to work on this and educate people through things like this Scholar Series. So let's focus on the first topic first, just a little background. What is the oldest nuclear waste in the United States? Well, the stuff that went to Hanford wasn't, it had to come from somewhere. And Hanford, of course, wasn't the first reactor. It was the first major production reactor. The first reactor where the humans were able to achieve a controlled chain reaction was in the squash courts underneath the stands at Stagg Field at the University of Chicago in 1942, December 1942. And it's just remarkable to think that they went from this rudimentary understanding of the emerging physics in 1942 to actually detonating nuclear warheads over Japan and testing a device in the New Mexico desert in 1945, just 3 years later. It is a remarkable event, whether it is good morally or not. It's an extraordinary sequence of scientific and industrial actions. Now, what happened to that reactor at Chicago? Well, here's what happened to it. It's buried out at a county park just out of Chicago. And as you can see, there's a granite marker there. And it is the place where they dug a trench next to the reactor. After the reactor was dismantled in downtown Chicago at the university, it was shipped out and rebuilt and operated for a number of years just outside of Chicago, not too far from where Argonne National Lab is now. And when that reactor stopped operating, they took out the fuel and much of the radioactive materials, but not all of it. And they just dug a trench next to it and bulldozed the reactor carcass into the trench and put this granite marker over it. And it was one of my interesting early jobs as a contractor to go out and inspect that site. So I got a little bit of history. So that waste, though, that came from the uranium operations at the University of Chicago came from St. Louis. And this is kind of typical for the way a lot of decisions were made. And it's easy to judge that, but it's important to think about what decisions we're making these days similarly. That is, the decision for where the uranium was processed that came from Canada and from the Belgian Congo at the time, Shinkolobwe, um, that uranium ended up getting processed in downtown St. Louis. Now, was that location chosen because it was ideal for protection of public health and the environment or for disposing of waste? No, it was decided because um, the Mallinckrodt owner had lunch with one of the directors of the early Manhattan Project, and he had explained to Mallinckrodt, look, I've been to all the big corporations, to DuPont, to Union Carbide, and they all refuse to do the extraction of uranium and purify it from the ore because they say it's too dangerous to mix uranium with ether because it's explosive and flammable. And Mallinckrodt says, well, no problem, I'll do it. Essentially because they had been classmates together at MIT. They cut a deal over lunch, and even without any paperwork, they started processing the uranium for the Manhattan Project. Partly in this building, but actually a lot of it happened in the alleyway right next to it. And so that may answer the question of why I ended up working in Missouri, because Missouri has, among the largest number of nuclear weapons production facilities in the country. So it got processed here in downtown St. Louis on Destrehan Street. And some of it was actually kept secret because the whole Manhattan Project was secret, even if it wasn't on paper at the time. And they had a sign outside that said the St. Louis Sash and Door Works. But you can see up here um, the pipes coming out from ventilation to keep the radon levels from the excess uranium inside the building when they're cleaning it up. So here is some of the cleanup that went on because there was a lot of uranium and solvents that were just left on the ground and it soaked into the ground. And uranium doesn't necessarily move very far unless you mix it with acids, which they did, and it soaked into the ground, into the groundwater. So you can see some of the groundwater percolating there, but the contractor kept digging, and you can see how deep the hole was. And it's not too far from the Missouri River. The Missouri River is just over here. The groundwater just kept filling up, and they pumped it. You can see the pumps getting the water out of it, and that creates its own set of problems because then you've got to store or treat the water. And they eventually didn't stop digging because they had removed all the contamination. They stopped digging because they're afraid the whole trench was going to collapse and it was a challenge dealing with it. So that was the earliest uranium. The work from Destrehan Street ended up moving outside. Some of the waste was moved near Coldwater Creek on Laddie Avenue. And that contamination has been the subject of several efforts to clean it up over the years. And as many of you are aware, there is increasing concern about some of the residual contamination found. And it seems like every time there's another study to look for contamination, people find it at varying levels. Now, whether it poses a measurable risk or not is a whole other debate. But more recently, as you can see, this is just in the past few weeks, the Army Corps of Engineers, who has taken over contracting for some of this work, has posted signs to tell people don't dig near the creek where some of the waste from the Manhattan Project work was left. And Kay Dry, as I mentioned, she is the one who has worked for decades tirelessly to draw attention to it, and is a dear friend. And she always is careful to remind me that this is the oldest nuclear waste in the world there in St. Louis, a little bit older than Hanford. Um, but the work was entirely moved outside of downtown St. Louis and a larger facility built to process uranium, essentially the same purification operation, but then they ended up doing more reduction into a metal, essentially the same kind of chemical operations that happened at Fernald. And this facility operated for 9 years, and that's an important number to remember for a number of reasons. We'll get to that. So from 1957 to 1966, the Weldon Springs site operated just across the river in St. Charles County, across the Missouri River, and processed uranium. And it was then left for many years without any cleanup at all, with some of the surface impoundments still there. And eventually, the site was cleaned up. We'll use that word here, remediated. And much of the waste was consolidated into an on-site tumulus. As you can see, the construction going on in about 2000. And eventually, it resulted in this 45-acre disposal cell. So the disposal cell was built in 2002, was completed largely. The processing was finished in 1966, and this is primarily uranium-238 materials in there. And so uranium-238, as you know, has a half-life of about 4.5 billion years. So this tumulus is expected to last for quite a long time. And that's the leftovers we have from an operation that only occurred for 9 years. So you have 9 years of nuclear weapons material production with almost an indefinite amount of time for thousands and thousands of years, if not millions. Now, what the implications of that are, how we do it, is still unsettled, and that's the topic of today's talk. So there now you can go visit. It's a sort of a tourist site. You can climb to the top. But again, any of these materials decays. I just took a very short decay material here, plutonium-238, that has a half-life of 88 years, relatively short in a greater scheme of things. But just to remind you, when you have a half-life, it doesn't mean that it's gone. That means that half of it is decayed. And it also doesn't mean that it's decayed to nothing. It decays to something else. So in the case of plutonium-238, it decays to uranium-234. And then that decays to thorium-230, the same kind of stuff you see in a Coleman lantern. And then that decays to radium-226. And then the good news is that it finally becomes stable. But the bad news is it becomes stable as lead. So lead is an element, so that is not going anywhere. So basically, lead is just old plutonium or old uranium. It just decays to it. And as an element, it's infinite half-life. It just is stable. So it's going to be around not forever, as my colleagues remind me, at least until the planet Earth runs into the sun or another star and causes a giant fusion reaction. These contaminants will be around. And to remind you, it's not just radioactive materials. So in Oak Ridge, Tennessee, of course, in Poplar Creek and the Clinch River, mercury was disposed of there. And that was actually Al Gore's first subcommittee hearing back in the 70s with or early 80s, excuse me. He eventually had some hearings with the staff director for Al Gore at that time was a person many of you heard of, Tom Grumley, who I worked for at Department of Energy. And the mercury is dumped in a creek because it's used for extracting lithium isotopes for the lithium deuteride secondary in nuclear warhead, which is what they do mainly at Oak Ridge. So the mercury is going to be stable. And when it goes in, it's elemental, but because of the nature of parts of the creek, it gets methylated and becomes bioavailable as methyl mercury. So the point is, there's a lot of old waste, and Hanford's not the oldest. Now let's examine this word cleanup, and I'm going to sometimes use the word cleanup as shorthand. But to be sure, cleanup is really remediation, and that's the norm. In some cases, for some locations, you can dig it all up, or at least as much as we can measure, but that's not normally what happens. Normally you remediate it because frankly, that's what the law requires. So there's a number of statutes that may be applicable. And of course, at Hanford, under the tri-party agreement, there's some sites that are subject to the Superfund process and some of them subject to RCRA corrective action or the Resource Conservation and Recovery Act. Depends on what the statute, but basically they all require some sort of a process like this, where you discover a site, you evaluate it, you designate it as a cleanup site, you do more investigations, you study the feasibility of different remedies, and you finally select a remedy, you perform that remedy, and then you do operation and maintenance, and then you delete it, right? All is good. That is still more or less the national priorities list, the NPL process under what's called the National Contingency Plan. That's the set of regulations governing how cleanups are done under Superfund. And the basic process, though, is a regulatory one, not necessarily a technical one. And I actually kept on this is a slide I used for training that I gave as a contractor back in the 80s, and it's still relevant. Things have not changed a whole lot. We changed the names, so we now do microsieverts for measuring radioactivity and so, instead of REMS. But the concept is the same. You're really trying to identify what is your exposure and what is your dose. I'm not going to get too detailed into the health physics of this, but there's a lot more that could be analyzed about this. But the point is that you do a risk-based cleanup. That's the key. We do risks in the United States generally for the general public. We assume that you should bring it down to a 10 millirem standard, although there are some cases where 25 millirem standard. So it's relatively low. It's down, within background to achieve. But that makes a lot of assumptions. And key to that assumption is you will cap the site or do something to protect it, to keep that radiation or radioactivity from getting out. And you then put in place institutional controls or some way of keeping people out of the site so they don't dig into it, or some way of keeping the site from getting affected by extreme weather, becoming more and more difficult, obviously, with climate change. So that's the basic process that we live with. So this word cleanup, again, I use it sometimes, but it really doesn't have much meaning, and it's generally not used anywhere. You could look through all the regulations, and the word cleanup doesn't appear. It's really reducing the risk to an acceptable level that meets the regulatory or risk-based limits, assuming land use controls. And that's really the focus of today's discussion. So you have different mechanisms that are used, but again, all of these different mechanisms are used. They assume that there's some land use control, whether you're talking about Superfund or RCRA, or under DOE, of course, it regulates itself under 435.1 with their DOE orders. And of course, more recently, Congress stuck its nose in with the 2005 Defense Authorization Act, and provides for a process for changing the definition of high-level waste to allow for different disposal methods of the material. And that's important for Hanford that we're going to see in a minute, because it's premised on how long the material will be hazardous. But the fundamental problem is something that I always liken to the old Dr. Seuss book, Cat in a Hat, where if you remember that or read it to your kids lately, the cat in a hat comes to help solve a problem where there is a spot that has to be cleaned up. And he wipes the spot off with a shirt, and then he cleans the shirt off against the wall, and the spot is then against the wall, and then that has to be cleaned up. The point is that the spot doesn't go away, and that's like the waste we're dealing with. This material decays at a very steady rate, and you can burn it, you can treat it with acids. It does not change the decay rate at all. It is a universal decay, whether you're talking about anyone on planet Earth or in the deep space, so far as we know, that decay rate is identical no matter what you do to it. And you can bring in the cat in a hat, or in the cat in a hat, you have the special device to get rid of the spot called the Voom gun. But there is no Voom gun, and there is no Cat Z to use a Voom gun. The material is just there, and it's going to decay at a certain rate. And all the wishing and all the good feelings you want in the world don't change that. And that may be bad news to some of you, but that is the reality. And I think that that's important that regulators say that to people and try to deal with that reality in public meetings, and not pretend that there is some magic cleanup. There is no magic cleanup. There is a way you can reduce the risk, but that risk reduction is premised on controlling and maintaining the site and passing on information to future generations and having it funded, and all the other things that go with long-term stewardship. As it was summarized in a great book, if there's one book I could recommend you all today, it is Donovan Webster's Aftermath, The Remnants of War. And he interviewed a certain Department of Energy official who said, well, we have a physics problem. The physics of radioactive material means that it's a decay at a certain rate, and that is just a reality. Now, one way to look at this, at least for me, that's useful is budget numbers. if you look at the annual cost for the environmental management program, this is back when we thought $6 billion was a lot of money, and it was going to drop. As many of you remember, there was a 10-year plan. The DOE said, if you give us extra money for closing sites, particularly Rocky Flats, Fernald, and Mound, we promise that that will reduce the overhead costs, and we'll be able to drop the annual budget for EM by the year 2025 or so. It'll be down to 4 billion. As you know, it's double that now. We're at about $8 billion for the EM budget. But key to it, if you look at the bottom end, and this is one thing I had focused on because I'd worked on this report in 1984 called the Superfund Section A1 31A1C report on the scope and cost of Superfund. And we found the same thing back then in this report to Congress we worked on, that even after you're done all the cleanup, you have this tail, let's call it, where there's a residual cost for maintaining the conditions at the site. That right there is the cost of long-term stewardship. Now, how much that is depends on how much you do up here. If you do a lot more cleanup here, then you have a less expensive tail. If you do less cleanup here, then that tail there is going to be higher. It's not going to be, as you can see there, it's about 1.5 billion or 100 million. It's going to be more like 200 to 400 million a year. And that's what we're still trying to figure out. And we don't know the answer to that. I think that public participation and it's going to have a say in that, we hope. So let's move on to the next question. I've mentioned already that there's a variety of waste and a variety of institutions. I just want to really reemphasize that so that we recognize that there are communities out there all over who share with the Hanford community the same questions and the same challenges. So this is one, just if I had one site I could pick that kind of had a whole bunch of these things all together as examples at one site. There's a site in Queens, New York, I worked on called the Quanta Resources site. It was sort of a relatively casual, unregulated oil refining operation, but they brought in PCB oil rather than regular oil. They refined it. And of course, when money got tight and the regulators started to pay attention to them, they walked away from the site, moved to Jamaica, and left us with the cleaning up the bag. So you can see we hired OH Materials. I was doing work at the time for EPA reviewing the technologies. So you had polychlorinated biphenyls, which is sort of the PFAS of the day in terms of getting lots of media attention. But here's a couple of interesting things about this site. In addition to the PCBs, and as many people may know, PCBs are persistent bioaccumulative organic material. There's actually a whole family of PCBs, and if you're working at a DOE site, you can usually assume they use the highest quality, most expensive PCBs, known as Arachlor 1260s, that last a very long time, very persistent. There's some other Arachlors that are at like an Arachlor 1242 don't last as long. They use the good stuff with DOE. So here we had some very long-lasting PCBs that we had to empty the tanks, get rid of the oil, and then of course the ground you can see was just soaked with PCB. You're walking through what seemed like mud, but it wasn't water. It was PCB oil and the dirt there. And right here is the let's see. First, the World Trade Center. That kind of puts a date on it. The World Trade Center was still standing, and I had just been working there the year before, so I kind of was thinking about how time moves on, and I figured the World Trade Center was going to be there for a long time, and I was going to get this site cleaned up. Little did I know that the site would last longer than the World Trade Center when I worked there. But also, the Newtown Creek is right behind there. You can look on a map, it comes off the East River. And one of the things we did there was study the oil, and the lab people kept coming back to us and saying that there is some mysterious type of aliphatic oil that is long chain, single bonded oils in there that he didn't know what it was. And I, frankly, was kind of trying to always meet a budget and keep on schedule. And I didn't really want to worry about that because my worries were the more hazardous PCBs and some of the more persistent toxic stuff there. But they kept looking at it. They were curious. What we found, long story short, is there was whale oil. They had hauled up whale carcasses off the Atlantic Ocean and slaughtered them on this site. And the whale oil soaked into the ground. And then decades later, the guy was refining PCB oil on the site. So the point is, these sites last a long time. There's a lot of history, people had figured that the whale oil was going to break down. It didn't break down because it had been then covered up with asphalt and PCB oil that cut it off from the sun and from any air and kept it from breaking down faster. Um, a lot of other industrial sites. Um, for Hanford purposes, some of you may know that Hanford serves a role in disposing of nuclear submarine reactor compartments. And this is a boomer sub, that is a ballistic missile submarine, for which we have still not begun figuring out a way to dispose of. That was a topic when I was at DOE, maybe building another trench. But right now, these are the earlier fast attack submarines. The reactor compartment is separated like cutting a salami. It's sealed up on either end, and there were some other regulatory issues actually associated with PCBs, and they're put in a trench at Hanford in the 200 area. And these are all the reactor compartments. Each one of those represents the reactor compartment of a nuclear submarine. And when I've talked to audiences of nuclear submarine officers, they're all very interested in figuring out which one was their sub over the years. And here's a picture of Bob Trudge he took just to give you a little more context. You see the person walking under it. These are very large reactor compartments. Now, to be fair, this is not necessarily the most hazardous of all the radioactive waste. It's largely activation products. The fuel was taken out. The fuel, of course, was sent for reprocessing or storage at the Idaho lab, the Idaho National Engineering Laboratory, and the reactor compartments are sealed up. And the Navy had done an analysis to look at what happens with the decay products. And they found that it really would decay within a few hundred years, and that the integrity of these reactor subhulls actually exceeded what NRC required for disposing of that kind of radioactivity. It would exceed the design life of 300 years for what the spoils around it. Um, so that's another type of waste at Hanford. It's usually something that gets people's attention. I'll tell you, there were a lot of new appointees to DOE who came in, and they were shocked that we were disposing of reactor compartments at Hanford. And you can tell them that it's not the worst problem, but it looks dramatic, so it gets people's attention. And of course, the bigger problem we all know is the liquid high-level waste from the acidic raffinate from extracting plutonium out of the reprocessing of the targets and the fuels. And this one is at Savannah River site in South Carolina. The same process used at Hanford. They first started building the tanks in the 40s, as most of you know. They were built with just single wall tanks, the first group of them back then, and a lot of it out of carbon steel, because the waste was then neutralized, and that creates its own set of problems. You add some caustic material to counteract the acids, but that adds to the volume and makes it more difficult to handle. But of course, over the years, those tanks leaked, and this is a computer graphic showing the leakage from the tanks at Hanford underground, that what we call the Vados zone. And each of these are either wells or lysimeter testing holes where we gathered data to determine how much radioactivity was there. So clearly, the radioactivity, right. When I first was working at Hanford as a contractor in about 1986, 87, we estimated that the plume of contaminated groundwater was about 60 square miles. I don't know what the current number is, but it was well over 200 miles when I was then later working as a federal official at DOE, not as a contractor. So the material just keeps spreading unless we do something about it. Hence, there is some urgency to deal with the tanks. And now there is a whole other process. We could get into this if people want to, but many of you know that there's a part of the urgency is to actually extract part of the tank waste that has the cesium-137, which is among the most radioactive. And of course, the paradox of radioactivity is the more intense the radioactivity, the quicker it decays. That's what radioactivity is. It's decay products. So cesium-137 decays quickly, so it has a shorter half-life, but during that, it's intensely radioactive. So one of the proposals is to develop a whole process for extracting the cesium. And that you then have to ask, well, how long is the cesium going to last? Um, just another type of waste that DOE deals with is the uranium mill tailings. Much of it on in the tribal Native American territory. This one's on the Navajo Nation territory. It's just we've got a couple of dozen of these very large uranium mill tailings disposal sites. This one is just one of the more, I think, one of the more photogenic of all the sites. Just kind of looks like a bat from overhead in Tuba City, Arizona. Um, this map shows kind of the fundamental way that we assume we're going to deal with radioactive waste in the United States. From all the trying to distill down all the variety of things I just showed you. We have high-level waste and low-level waste, and in a minute we're going to talk about transuranic waste, but we have activation products. But the assumption is that if it's high-level waste and spent nuclear fuel, which is a particular type of high-level waste, then it's going to go to a repository. That's the assumption. We don't have a repository. It's not clear when we will or if we will, but the assumption is that it's going to go from all these locations. And the proposal for a number of years was to build one in one of the only states that does not have any radioactive waste from spent nuclear fuel, at least, in Nevada. Obviously, there's a lot of contamination from nuclear weapons testing and from now disposal of low-level waste. But that's the basic idea. You're going to take it from all these other places and put it in one site, sort of like the Alice's restaurant method of waste management. Instead of picking up the garbage from down at the slope, you put all your garbage in one place. So that's the assumption. But for all the other materials, we are not presuming that it's going to be taken, consolidated into one single National Geologic Repository. The assumption is that we're going to remediate it to reduce the risk, and that we call cleanup. And that's risk-based cleanup. So just to draw a contrast between how we assume we're going to deal with spent nuclear fuel and high-level waste to how we deal with all the other radioactive waste and contamination. We sometimes take for granted this is just the way it's done. Well, this is the way we've chosen to do it. But right now, we haven't moved this waste for the most part. There's no repository, there's no interim storage. It's just sitting at the reactor sites and at the 4 reprocessing sites. We have reprocessing at Hanford, obviously, Idaho, West Valley did nuclear weapons material reprocessing here in Western New York. And of course, Savannah River. We have 4 of those high-level waste reprocessing sites. And the one paradox is that you're looking at all these dots on a map, but most of those are nuclear power sites. And nuclear power sites pose, frankly, a much, much lower risk because the material is kept as a solid and contained, and also it's subject to independent external regulation by the Nuclear Regulatory Commission. And many people would argue that they might criticize the NRC, and I would recognize it's not perfect, but it is independent and it's subject to more public review. With the DOE sites, DOE regulates itself, and that is a fundamental difference between the dots on the map. Most of the dots are nuclear power that's independently regulated, but the risk really is focused on just the 4 reprocessing sites for the high-level wastes for DOE sites. And this is written about extensively in Arjun Makhijani's book with Scott Zaleska called High-Level Dollars, Low-Level Cents, which I recommend to you. It's relatively short, so it's painless. They do a great job of kind of analyzing how we define legally high-level waste and compare it to some of the waste that's considered low-level waste in the United States. Another type of site is the plowshares sites. The plowshares after the Eisenhower speech from the biblical reference of turning swords into plowshares. And many people don't know that we actually exploded nuclear warheads outside of Nevada and outside the South Pacific sites where we detonated nuclear warheads. This one we detonated two explosions in Hattiesburg, Mississippi. And here is the notice you get if you are visiting Hattiesburg. It'll tell you no excavation, drilling, or removal without U.S. government permission. Some of the other markers tell you that you should contact somebody at the Atomic Energy Commission, and I think that would be a challenge if somebody were to look up in a phone book or look up what number they should call for the Atomic Energy Commission to find out about these nuclear explosion sites. And of course, another one of these Pash's tests was the gas buggy test, try to encourage natural gas production, early nuclear fracking that's now in a national forest. These are not necessarily at all pose any risk or hazard right now if you walk across them or ride your bike over them or hike or whatever, picnic. There is virtually no risk. There's no measurable contamination. In some cases, DOE has gone back and checked, and the Legacy Management Office inspects them and has done some cleanup to deal with some of the issues. A lot of it not even radioactivity, just some diesel fuel or things like that that they've cleaned up. But the point is, it's there, and the depth of 4,000 feet is not something you're going to do digging a fire pit for a picnic. But at some point, people could drill down there, and there's a need to communicate and warn people about drilling in these sites. So here's the central question that I think we have to answer. Who cares about any of this? The first one, of course, is trying to protect people from digging it up, particularly our kids digging up the waste in the future. But it really is a part of a management idea that was made famous by Dwight Eisenhower that he encouraged his officers to focus on. And he split the world of decision making and management up into 4 quadrants with the segments for urgent versus non-urgent and important versus not important. And what he wanted people to do is recognize that there are some things that are important but not urgent, and that's where the officers should be thinking about planning for their troops and their people. But there are other things that are urgent that have to be dealt with immediately. So you have important things that are urgent you've got to do in the short run. So you survive in the short run by dealing with these quadrant 1 activities. But long-term stewardship is important, but not urgent. It goes into quadrant 2. And he was trying to get his officers to really spend their time focusing on quadrant 2 problems because he had great confidence in the non-commissioned officers and the troops to deal with the urgent things and to deal with if they were important enough to deal with right away. But that the officers need to be thinking in the long run about things that were not necessarily urgent, but terribly important to make plans for. And that's really what I'm hoping we have institutions who can be adults enough to focus on and not just kind of, play junior high soccer with the environmental issues of everybody run to the ball and kick the ball all together. Let's think about the long run. I mean, that's what the heck we are supposed to be doing. The alternative, and this seems to be going on like right now, is what I call the sheet cake method, where you set a goal and then you declare success, you have a sheet cake, and everybody goes home. You're done, right? You celebrate that you've done something. You've finished cleanup, and that's where this word cleanup can be so insidious because it suggests that there is a termination. They just have a sheet cake and some punch, and everybody goes home because you've declared success. And that can lead to what some people have called semantic detoxification. You use the wording of it to just declare that it's all done. Now, I don't want to dismiss sheet cakes. My sister makes a lot of sheet cakes. And, as a day-to-day manager, you got to celebrate individual success, like finishing a quarterly report or finishing a particular project. So you've got to celebrate these small things. But let's not confuse that celebration of individual tasks with a bigger picture that says, okay, we can just walk away. We can't walk away. We have essentially made a deal with people. We've said we're going to do risk-based cleanup. It'll be protective and reduce your risk below acceptable levels, but it's dependent on a deal. The deal is this, that if you accept that we're not going to dig everything up and send it somewhere else and make it their problem, then we will promise that we'll take care of this indefinitely. That's the deal. And unless we take care of it indefinitely, we're breaking our promise to the people who we've worked on the cleanup with to do risk-based cleanup. And among the people we risk breaking the promises with are the workers. And again, this is what Hanford Challenge has done so well over the years, is working with labor unions. This is not a DOE site. This is just a regular old dry cleaner. And as you know, dry cleaners typically have perchloroethylene or tetrachloroethylene. It often leaks from tanks traditionally into the ground. And workers who are just trying to, go to work every day and dig a trench to put in a new fiber optic cable or to fix a water line, they could be exposed to fumes from the leaking underground contamination from a dry cleaner. And perchloroethylene lasts a long time. Maybe not as long as plutonium, but depending on the circumstances, it's going to be there for many, many decades. And that's just sort of a typical exposure that workers might run a risk of unless we keep track of. So after you finish a cleanup, you got to figure out where did the contamination go and how do we protect people in the long run. And right now, this is not thought of as a cleanup, but as many of you know, we have tens of thousands of 12 and 14 ton cylinders of depleted uranium hexafluoride at Portsmouth, Ohio, Paducah, Kentucky, and Oak Ridge K25 in Tennessee. And right now, we are undergoing a process that's expected to cost about 11 billion, almost $12 billion. It's going to take another 30 years to finish or so. And until that time, these workers are out there inspecting them every day and assuming that people are going to be able to monitor it and pay for the monitoring to protect it. The UF6, or depleted uranium hexafluoride, is actually not so much a radioactive risk, but the fluorine, if it gets out in the air, creates hydrofluoric acid and is extremely caustic to your lungs. So it's just a huge occupational worker exposure that, for all intents and purposes, 30 years is a long time from now, given the way the world has changed and people are proposing to change regulations and change bureaucracies. Who's going to protect that worker there in 30 years? And at Hanford, of course, we've seen changes. This is what the aerial photo of the Hanford reach of the Columbia River looked like in 1941, before Hanford was built, really, and also before there was extensive irrigation on the scale that we subsequently saw for all the farming and orchards up there. And just keep an eye on the island in between and the white bluffs that, if you haven't done there, I highly recommend getting out there in a boat. It's just extraordinarily beautiful and eminently swimmable if you're a decent swimmer. And just fast forward then to 1996. The bluffs had collapsed, and many people believe in large part because of the irrigation up there. But of course, happened to the river flow. The river is then diverted by the collapsing cliffs, and the concern is that it would move over onto the other side of the river and start eroding the south side of the river there. And of course, that's the 100 area where the reactors are, where we've now cocooned for safe store for indefinite storage. I'm not saying there's a huge risk of those reactors right now. It's just an illustration of how things happen over time in ways you might not expect that we have to think about for long-term stewardship of these sites. And of course, Rocky Flats in Colorado, that was the site that produced the plutonium pits for most of the Cold War. This is actually from, you know, long after Rocky was built. When Rocky was first put in place up against the Flatirons outside of Boulder, there was nobody living in that area. And as you can see, the suburbs are spreading almost as you speak. There's some people who live in there now and have more suburbs. And I'm not necessarily saying that they are clearly at risk. That requires a lot more analysis than I have available to me right now. But the suburbs were creeping up on a site that people had assumed was going to be remote and cut off from a lot of people, and it just wasn't. People started moving into that area. And when it was built, this is an aerial that shows how remote it was, nobody around there at all. When the site was finally closed down, the last pit was shipped out in 1989, and the funding was pretty much secured with a plan to do the remediation in the late 90s. It looked like this. Again, right at just a beautiful spot up against the Flatirons of the Rocky Mountains, with Boulder over here and Denver further away down this direction, and Broomfield, Nevada, up along here. All these are little suburban towns that got built. And then finally, the site was remediated. I'm going to be very careful not to use cleaned up because there is residual contamination there. But the goal was not to clean it up completely. The legal obligation was to meet the risk-based cleanup standards to ensure that the risks would not exceed a certain level, assuming the future land use was controlled. And in this case, the future land use for the site was to create a national wildlife refuge for almost 5,000 acres of the old site and a central DOE core area where no excavation can occur of 1,300 acres. So pretty significant plots of land there. And I know that there's a lot of concern by some people about the contamination, but this is a site that went through an enormous amount of stakeholder input for years, decades of meetings and analysis, and they met the standards that were required of them. And this is what we call cleanup. It's remediation of a site to reduce it below a certain level. And again, I'm going to repeat that it's this this risk-based cleanup is all dependent on controlling the land use, so people are not exposed, they don't dig into it into the future. And one of the serious problems we face right now, and perhaps I hope is a value of talking to you today, is that unless we get serious about the long-term stewardship, we get serious about a way of creating institutions and creating controls, then we're really not being honest to people, and it undermines not only protecting public health, but it undermines the integrity of the government and the government processes that have made these assurances to people that they will be protected, but that protection is dependent on controlling land use and it's dependent on long-term stewardship. And the question of how we do that is still yet to be done. But I'm going to go back to cost because, for me, numbers are comforting. I can sort of understand things better. This is an analysis that we did to look at the options before us generally, and this is just for actually, these are real numbers from thousands of individual waste and contamination sites that were rolled up at the 5 biggest sites of Hanford, Rocky, Savannah River, Fernald, and Idaho, I guess, and looking at what the trade-offs were. So you have 2 lines here. One line is if you accelerate the cleanup, you spend a lot more initially per year, and you keep spending that for a number of years. So we're looking at, for those 5 sites, about $400 million right up to 2030. And the benefit of that is if you do a lot more cleanup to it, cleaning the site up, then you have a lot lower long-term stewardship. That's the base case, and that's what DOE is seeking to do, is to minimize the long-term stewardship costs. Whether or not DOE is successful at that is another question to be determined. And well, we're now in the process of figuring that out. So watch the budgets. The other option is to spend less per year over time. So instead of have a spending level like that, you have a spending level down here, and that means you can have an indefinite higher cost for long-term surveillance and monitoring or long-term stewardship. And I think it's a question, a policy question, a question for society. Are we willing to pay that higher cost to provide long-term stewardship, or should we drive down the cost by spending more on cleanup now and have a lower cost for long-term stewardship that makes it more affordable and more possible in the future? This is another analysis, another way to look at it. One of the concerns that people accused DOE of was actually spending too much money on cleanup, and that you're trying to make everything to be pristine conditions. And so one of the questions we asked is that really what's going on? When we roll up the thousands of individual sites across the country and say, okay, what's the goal that's being sought here? And we have a range of land use options here. On one extreme is what's called the iron fence. We basically put up a fence around here. I wanted to put steel fence, but people, just because of my background of crawling under steel fences, but we call it the iron fence method of just putting a fence around the site, not doing much cleanup at all. And then the other extreme is the maximum feasible green fields, and that's kind of the pristine situation. Or you can call that the Garden of Eden scenario. That would cost you $284 billion life cycle cost. And that is in no way what people were doing. What people were doing is called the base case. That's just the status quo of negotiating individual site by individual site with regulator by regulator. It'll cost about $160 billion. Again, this is just for the 5 sites, not for the whole DOE. And if you look, the base case is really not that much more expensive than just putting an iron fence around it, and not very much less expensive than what's called the modified greenfields, which is how you do everything reasonably possible that it kind of fits within the national contingency plan. So it's all within the same range between 150 $166 billion. So just the reality that was telegraphed very clearly in the analysis done in 1996, and this has been repeated a number of times subsequently, is that we're going to have long-term stewardship. We're paying for something that is not the Garden of Eden scenario, but it's also not the iron fence. It's somewhere in between there. So what we do about the long-term stewardship, again, we're still trying to figure out there. That is really what we're orienting towards. And this is what you buy after you spend what's now estimated to be nearly $1 trillion of the so-called cleanup or remediation of all the sites. This is just a map of the United States showing all the dots where all the contaminated sites are. And you'll notice that at least as of this telling in July 2024, there's no dot for Hanford yet because that's not yet on the list. This is just a map showing where all the completed cleanups are that require some form of long-term stewardship. So this is a reality. This is not something that's going to happen in the future that we have to wonder about. It's happened. So look behind you. We already crossed that line. It's happening right now. So what we do about it, again, is the challenge, and I hope there's some ideas. But the challenges and the why we should care, I think has some you have to look, each site has a different scenario. And I think the WIP site is an interesting one where, frankly, they've done more consideration of long-term stewardship than many sites around here. The WIP site, of course, is the Waste Isolation Pilot Plant in southeastern New Mexico, where the United States has established a deep geologic repository for transuranic or plutonium-contaminated so-called defense waste there. And it's about a half-mile underground in salt beds that are mined out where we've been disposing of materials since 1998 there. And there are different rooms that keep getting dug out. And the idea of salt is that it slowly creeps in and envelops your waste so that it is more naturally likely to contain it. That's the idea. And there's some analyses, as I said, there's been a lot of study, a lot of consideration about it. How do you deal with the fact that there's some pressurized brine deposits under there that may be attractive to future generations? How do you market? And you've got an increasingly large area underground where this transuranic waste disposal has been happening. How do you protect it, from getting infiltrated in the long run? So there's a number of laws and things. I'm not going to get into the details about each of those, but the fundamental law governing it right now is the Land Withdrawal Act, and there's regulatory requirements called the waste acceptance criteria to ensure that it is at least as stable as possible before it goes in. It's got a fixed capacity under law, and the question is, how much more can it take, particularly because we've changed the mission from just taking waste. So now we've got diluted plutonium from warheads going in to WIP in the future. And part of the challenge is, you've got not just a limited capacity I mentioned, but you've got waste that's plutonium contaminated defense waste that's not going to WIP, that is just buried and there's no plan to clean it up. So when people say, don't worry, the plutonium waste is going to WIP where it'll be secure, and there's obviously been a lot of work done, a lot of regulatory review of that decision. But that doesn't mean all the plutonium is going to WIP for disposal. And here's just one of a number of places. Some of the waste at Idaho has been dug up, and maybe it will be in the future. But right now, the plan is to keep much of the waste and many of the sites right in place. It's not going anywhere. There's a number of completion dates for and I think we kept the word cleanup out of here. I have always advocated for not using that word just because it's so kind of meaningless. So you can get this in the annual the EM budget, which I recommend. I know it's a little tough reading, but it really is the kind of the main source of information about what's going on with cleanup and environmental management. And this is among the many things that it's DOE's way of meeting the legal requirements that were originally met by the baseline environmental management report. Um, One of the studies that a researcher did was looked at not just inadvertent exhumation of WIP, but what if somebody were to go into WIP and actually drill into it purposefully to try to extract out the plutonium from the site? And in this case, he got into the details of how much lixiviant or a solvent would then dissolve the plutonium, bring it up to the surface, and then separate out that plutonium. And some people would think this is, an extreme scenario that couldn't possibly happen. I have to say, this is exactly the scenario that Minatom in Russia had in mind when they were negotiating the plutonium management and disposition agreement regarding the mutual the treaty or an agreement to dispose of excess weapons grade plutonium. He was concerned that without isotopic uh, dilution of the excess plutonium, you could do exactly what you're seeing in this picture from the Harvard researcher, and that is extract the plutonium and bring it back up. Now we have a plan where we're using something called Stardust that's supposedly effectively making this impossible. And the question is whether or not that is it. The point is that we have facilities where there's been a lot of work, but there's still questions about what is going to be the long-term care for these sites. And similarly, just where we get a lot of our uranium right now, and we certainly got a lot from the nuclear weapons process in the Cold War from Canada, where it was processed at the Cameco site in Port Hope, Canada, just over the border, just outside of Toronto. Um, Most of the contamination comes from one process, and this is from the Linking Legacies separation that we then did the cost analysis for in the baseline report. And I know this is a lot of numbers. Let me just focus on generally. You'll see 8 categories thing here. You see the big black area is for one of those categories of activities. So each of these categories is an activity that happens in order to make a nuclear warhead. You start with mining uranium, you enrich the uranium, you make targets out of it, you irradiate in a reactor, and then you do chemical separations, which is reprocessing to get the plutonium, and then you can fabricate that into components and make a warhead out of it. That's essentially the 8 steps to make a warhead. More than half of it, the waste and the cost for dealing with it and the environmental management program comes from one step only, and that is the reprocessing step that happened at Hanford and at 3 other sites, West Valley and Idaho and Savannah Riverside. So this is a big consideration in terms of the cost. So if you look at the total cost at that time, it was considered to be about a quarter of a trillion. Now it's estimated to be nearly $1 trillion. Half of it is just for reprocessing costs. And of course, it comes from these canyons that I always thought these should be the center of attention for Hanford historic preservation, but the Park Service, of course, is focused instead on the reactors. The reactors, are certainly interesting, but that's not the source of the main contamination. It's the reprocessing canyons that generated the waste that went into the tank farms. And this is just one of the canyons there. The T plant was the first one that made the Nagasaki bomb, but this was the workhorse for plutonium production throughout the Cold War. And it generated the waste that went into the tanks. And the tank waste, the idea is to vitrify, that is, mix it with borosilicate glass and put it into stainless steel containers and then send it to a repository. That is already happening, at least the borosilicate glass part, at the Savannah River site in South Carolina. And the idea is to build one, as many of you know, at Hanford. The question is how much of the waste you take out of the tanks, and can you leave some of the tanks, and can you separate some of it for doing something other than borosilicate glass and maybe just mix it with concrete and grout and maybe just put grout in the tanks. And that, in fact, is, of course, what's happening at the Savannah River site right now. And the question is that also going to happen at Hanford? Here's what the cylinders look like for people who have not seen them. It's Savannah River site. Obviously, these are cold cylinders, so those people would not be standing there. But they're eventually put in what's called the glass house for temporary storage, so that it's a lot more contained than if it's a liquid and a waste tank. And that is for, that's for trying to blend all of the high level waste. And that was the requirement, is to take all the high level waste out of it without relitigating the whole litigation behind the waste incidental reprocessing. That ended at Savannah Riverside. So now they're grouting the tanks with concrete. But that is not necessarily what's going on at Hanford now, but it might be. So again, the concern is leaking out of the tanks and how to get it out quickly, but how to do it in a way that protects the workers and is affordable within the budget. The concern is about leaving it at Hanford for this long of a period of time. So you've got the urgency of getting it out. Remember the management quadrants, but you also have the long-term consideration of the site. So Hanford is essentially in this area in this map. Just shows the flow of the Ice Age floods that Tim Connor wrote about so extraordinarily well in his book that he talked about in an earlier webinar. It was about 2,000 feet deep of water that came out of Lake Missoula and washed over what's now the 200 West area and 200 East area. This is where the tank farms are right now. So how do we protect these areas from another flooding that is likely to happen maybe in 10,000 years, maybe sooner, depending on a whole lot of other factors, including climate change. So the Tri-Cities, this is the flood that happened. They washed down, and the Tri-Cities is right there. So the Pasco Basin, which is where Hanford is, right north of Richland, Kennewick, and Pasco, was just another lake. It was held up by the Wallula Gap here along the Columbia River. And here is Tim Connor exploring the Wallula Gap along the Columbia River that he wrote about so well. So again, with commercial fuel, it's a solid, it's put in canisters, but with Hanford, you've got the liquid waste. Now, the question, as I mentioned, is how to deal with the tank waste. And this has been a subject of much study over many years, including by the Government Accounting Office, or now known as the Government Accountability Office, and the National Academies of Sciences. And essentially, to oversimplify perhaps, the idea is to separate out chemically some of the shorter-lived materials like cesium-137, strontium, americium, technetium, all those fission products, and solidify those in a much less expensive way, like grout with cement, and then have the long-term material that requires solidification for many hundreds of thousands of years into borosilicate glass. So you treat the long-term stuff with a long-term remedy and the short-term stuff with a short-term remedy. And so in essence, in terms of radioactivity versus volume, so if you look at the smallest amount of volume, it's in the sludge at the bottom, about 10 million gallons at the Hanford tanks. But about more than half of it, half of the radioactivity that is in that sludge material. So the idea is to get more bang for your buck by solidifying with grout the largest amount of radioactivity that's going to decay. Again, that paradox of the greater the radioactivity, the shorter the half-life. And the supernate, which has the lower amount, it's usually to deal with in some ways. So the main amount of radioactivity you can see is mainly right now in the cesium and strontium, which are the fission products. And because it's so radioactive, it's going to decay a little faster. What do we mean by faster? Today is all about time. So the proposal to separate them suddenly got a lot more attention recently by the incoming administration's book put together by the Hanford Foundation. And remarkably, at least to those of us who follow such things, it got more attention than any of us expected for a new incoming administration. They actually had a whole little section about Hanford where they recommend revisiting the whole regulatory framework and then fully implement what they call the high-level waste determination, where they can determine that some of the waste that's now considered high-level waste is actually low-level waste and can be grouted rather than vitrified. So that's the question before us. And so as we sit here in December of 2024, I think that it's not unreasonable to expect that there'll be a lot more pressure to implement that option in the future. It's not a new idea that sprang forth just from the Heritage Foundation. Again, this has been proposed for a number of years by various people to deal with the short-lived material versus long material. And the reason I'm bringing this up is because it's relevant to long-term stewardship in defining that short-lived versus long-lived material. So here's a National Academy of Sciences study. And the idea is you fill the tanks with grout rather than pump it all out. So let's look at the basis for it. Now, this looks like a lot of gobbledygook. I'm going to deconstruct this for you. Believe me when I say that I'm going to try to do it in a simple way and separate all this stuff out to make sense of this whole proposal for separating out the short-lived versus the long-lived. So this is the way it's normally presented. So let's break it down. So the short-lived is the fission products, okay? The strontium, cesium, and it decays quickly. You see this drop off in the amount of curies, the amount of radioactivity, and it drops off because it's intensely radioactive and it's decaying down. So within here, see here, this is a log scale, so that's 300 years. Most of it decays down within 300 years. Okay, so keep that in mind. Fission products decay in about 300 years. That's the kind of the simple story there. But then the longer lived stuff, what we call actinides. Actinides is just a way of referring to some of the longer lived materials like uranium, plutonium, neptunium, to the extent that that's a concern. They last a lot longer. So again, the radioactivity at 1,000,000 curies, it's decaying. There's no precipitous drop off a cliff type of the radioactivity. It's going to decay almost on a linear or a log format going out to 1,000,000 years before, and down below at the bottom axis is where it becomes similar to just natural uranium in the dirt outside in your garden, in your houses today. This is a normal amount of radioactivity. Well, that's what we have a plan to protect against in a repository for very long periods of time, as well as the short-lived material. But the idea is if you separate those out, you can deal with something, a cheaper way to deal with the shorter-lived materials. So let's just think about that. So if you combine those together and you ask yourself, okay, what's the total amount of radioactivity when you combine the two of them, the fission product curve versus the actinide curve and the decay of those, if you look at the total radioactivity, initially it's defined by the fission products, and then for the long term, it's defined by the actinides over the long run. And the question I guess I would have for you is that let's go back to the fission products, 300 years. So that's considered the short-lived material. And I would propose to you that 300 years is still a very long period of time for which we don't have any institutional experience for maintaining the controls over to protect people for that period of time. That is just a consideration as we get into the debate about what to do with this material, and that's yet to be seen. So separating those out, which is going to cost, be a significant change in the plans for Hanford, is all to deal with the fact that some of the material is called short-lived, and I would just propose to you that 300 years is not very short in kind of a bureaucrat's way of thinking. And to remind you again, the flood that came through Hanford, that's more in the order of 10 to 20,000 years ago, it was 1,000 feet deep. You had icebergs floating by Richland like that, floating. So you'd look up in the air, or look up from, if you're in Richland, you'd be looking up through 1,000 feet of water to see icebergs floating by you in the area. So, and Dewey actually has looked at this in their own performance assessment, which is an important tool for looking at the source terms of radioactivity and the transport of that material and who might be affected. Now, Dewey's done land use studies, and for the people who've seen this, you probably have enough of it, but the idea is that you could protect certain areas like the 200 area, and then the rest of it you would clean up to a different land use to protect people assuming different land use. But again, you still have the reactors up on the 100 area on the shore of the river there. And of course, we've already had some experience of dealing with these 300-year low-level waste, mainly of the fission products. This is just one of the landfills at Savannah River site with the B25 boxes that go on and on and on, just thousands of these being disposed of with no external regulation. This is not regulated by the Nuclear Regulatory Commission. Now, more recently, we've put some of the material into grout into these saltstone vaults. We now do them in a circular pattern there. And of course, the site I showed you earlier, this material lasts even longer. Its major hazard, of course, is radon exposure from inhalation. Now let's we looked at Hanford, the WIP site before, underground at WIP. Now let's also look at WIP, not just in terms of potential for extracting material, but the current activity right now, not in the future, but the oil and gas drilling that's happening in New Mexico. And in 2002, just a few years after WIP started operating, here's a map showing the oil and gas wells around WIP. So this is the underground area of WIP. This is a buffer area. And the idea is the buffer area will keep people from drilling wells inside the protected area and drilling into WIP. So this is 2002. So let's look at how much interest there is in oil and gas drilling around WIP. So this is the oil and gas drilling just another dozen years later. In 2018, you can see that the wells are often right up against the border of WIP, trying to get into the areas where you can get oil and gas in the area. And then this is, you can see even a greater cluster, and just 4 years later in 2022 around WIP. And the fact is that DOE is mapping this, and this is made public. The challenge is, how do you keep mapping it, and how do you keep protecting it, and how do you keep informing people of the oil and gas drilling risks around WIP, and how do you prevent them from drilling through it in the future? That's, again, the challenge of long-term stewardship. And of course, the interest in drilling is affected more by price than anything else, by regulations. So you have an increase that I just showed you those maps. The two spikes happen when you went from a low price to a higher price where it's worth people's while to drill into WIP more, or to drill nearby WIP. Excuse me, they are not drilling into WIP right now. They have an effective way of protecting it for now. The other aspect that I just mentioned is that what we do here in the United States has an impact on other countries. When I had the opportunity to meet with the director of the Fukushima cleanup in Japan, he was very interested in what we're doing, because they obviously have an evacuation area, and they're trying to determine either how do they clean it up, how do they make a decision on when to let people reoccupy those areas, and how to provide long-term stewardship protection of those areas. So this is a very real problem for which the Japanese are looking to us for a little guidance. And I, talked with them for a long time. I felt a little frustrated that I wasn't able to give them more help. But, the National Academy of Sciences looked at it, and their conclusion after a number of years of study was simply institutional controls will fail. Or as my friend Dan Miller in Colorado said, institutional controls are fine. The problem is that there's no institutions and no controls. And of course, we saw that at Love Canal, where famously a canal was filled with waste, and people ended up building houses on top of it and got exposed. And that was really the genesis for Superfund. And what many people don't realize is that the Hooker Chemical Company, who disposed of that waste, they actually put a deed notice with information about the waste that was disposed at Love Canal to warn people about building on it. And of course, people built on it really within a year, started building houses nearby, and it resulted in exposure. So this piece of paper didn't protect people. The question is, what will? All right, so what do we mean? How can you do long-term stewardship? And that's something that's still yet to be defined fully. And there's a lot of people who have tried to address that question. So let me just give you one definition, recognizing that there are many out there. So in context, you start with building nuclear warheads, right? That's DOE. And then you have the cleanup process. It involves, after you release the contamination to water and soil, you do some remedial action. That's what we've been talking about, or you dispose of it in waste. And eventually, it all comes out to long-term stewardship. So that's the goal of everything. So if you begin with the end in mind, using the Stephen Covey management mode, that's where you're going to end up. So you got to focus on, how do we do that most successfully and at the lowest cost overall. Um, there's six major components that the National Academy of Sciences identify for long stewardship. And just to recognize, before you even get to consideration of long-term stewardship, they said that first you need to reduce the amount of contamination you create, and then you have to do your best you possibly can with isolating it. And that's, of course, what we're talking about with doing cleanup right now. Of course, the ship has already sailed on minimizing the amount of contamination we've created. We've already created a lot, and now we're trying to figure out how we isolate it and solidify it, or protect it. Once that is done, though, what do you do for long-term stewardship? And their recommendation is that you identify people to do each of these six tasks. The first, of course, is what many people think of. Mainly the lawyers think about institutional controls for the site. And a number of states have actually enacted statutes to help with that. We can get into, if people are interested, questions. You've got to then oversee those controls to make sure that it's actually being done, and have a way of enforcing it to make sure that you control access to the site, to make sure people are not digging into it, or make sure kids are not crawling under the fence again. You gather, you store, and retrieve the information, which we don't really have a great way of doing right now. Um, Though DOE is trying with their legacy management office. Um, the the separate function, though, is after you've got the information, how do you disseminate it and communicate it to the public? I have to say that I can almost set a clock. Every 5 years, I get calls from people living around St. Louis, or every 5 years, somebody will call me about Rocky Flats or Weldon Spring or Santa Susana, and they will say, gosh, I just discovered that there used to be a nuclear weapons production facility around here, and somebody told me I should call you. Nobody has ever heard of this. It's been a big government secret. They're hiding it from us. And so I send them information, and then 5 years later, I'll get another call from people who have never heard of these sites before. So how do you distribute that? Because I'm not going to be around forever to take these calls. So how do you then make sure you go back and reevaluate these remedies to make sure they're still working? And that's more of a rigorous technical operation than just the immediate keeping people off the site and oversight. And then lastly, how do you evaluate the science and maybe invest in the science and technology? Because it could be that some of these contaminants are less hazardous than we thought they were, but they're more hazardous. Or maybe the remedies we thought of are going to break down sooner, or maybe they're going to last longer. But you got to have a way of investing in the science and technology. So all of these components are part of any effective long-term stewardship program. And missing any of these, I would argue, is less than a full long-term stewardship program. And sometimes it's a little, when you talk to people about it, it's a little like the blind man and the elephant. So if you talk to lawyers, they're going to tell you, well, it's all about institutional controls and enforcement. And if you talk to, it's the engineers, they're going to say, oh, well, it's all about just evaluating the remedy and doing repairs. And if you talk to financial people, and that's something that's left out here, the mother's milk of everything is, how do you provide reliable funding to do all of this, the work that's got to be done? So that is the task that's set forth for us to do, so we can make good on our promise that we've made to people, that in exchange for allowing people, allowing the government to leave the contamination in place to some extent, the other half of that promise is that government will take care to protect people in the indefinite future. And it's not clear the government's prepared or capable of doing that. And it's for a long time. So finally, just how do we communicate to future generations? I'm going to simplify this into two ways. One is to, um, kind of we'll call it a Hail Mary pass. You take a bunch of information, like it was considered here in this Sandia report, and you throw it into the deep time. Sometimes this is called semiotics. How do you communicate with a different culture, a different generation for 1,000 years in the future? So you put together some message and you try to communicate to people who might be around in 1,000 or 10,000 years. So this is the Hail Mary pass, or the semiotics method of trying to communicate people for a long time. There's one study in 1991 was done, another in even earlier in 84. So this was done for WIP. This was done for the high-level waste repository, communicating to future generations. And you've probably heard about these. But there are proposals to have cartoon graphics about people dying if they dug into the ground, or having scary spikes coming up from the ground. And I looked at these and I just thought, yeah, I crawled under the fence at a place that they told me was scary to stay away from. I don't know how much did this cost. But it certainly uh, is involves some imaginative thinking about marker systems in the future. One thing that I found interesting visiting Japan was the markers they put in down to communicate to people in future generations about tsunamis. They're not new. Japan is built near a fault zone where they have a history of earthquakes and tsunamis. And these marker stones were built. You can see they were the road is sort of down here a little bit, and then you go up the hillside a little bit just off the road, and you can see these marker stones that kind of line a certain elevation off the road. And what it said was, don't build anything below this, or well, a little more artfully than that. High dwellings are the peace and harmony of our descendants. Remember the calamity of the great tsunamis. Do not build any homes below this point. Well, that didn't work. So what do we do from a regulatory point of view? So a few suggestions. Right now, we have in place under the Superfund program a so-called 5-year review program. And that's a completely different way. So I mentioned the Hail Mary method. This is the other method, which is you pass it on from generation to generation. Sometimes this might be called rolling stewardship. So the best we can do is just pass it on from one generation to the other. And Liz and Mia, hopefully you're going to be around for a while, because I am not. I'll be dead not too long, and you guys will be around to hang on to this. I'll do the best I can, but I'm glad that you're here. So we do these 5-year reviews. They're done with EPA, the states, and DOE, and this is more the rolling stewardship method. There is an office within DOE called the Office of Legacy Management, relatively small, but still $200 million is not nothing. And they have not only a field effort to go out and inspect the sites and maintain them, they're investing in some new technologies. They're trying to communicate to future generations with public programs about the site, and then some information retention and library systems. There's other things that maybe they could do, but it's a program, and I was actually the first director of this program when we first created it after Beamer and long-term stewardship. I guess we created my office officially in 1999, but we really started making plans for it in 1996. And they're now an official separate office. But one of the things you might want to look for, if anybody again is reading the budget, the FY 2025 budget says for this office that the 2025 request allow legacy management to increase activities for its foundational environmental justice program, enabling the program to reach a larger number of affected communities. And one question is, by the time it's enacted, will this be implemented? Something that somebody might want to take home as a little homework assignment. Check on that. So some organizations have been created to do this, so that's an option that the government may want to undertake. And this is one of the options that we can look at for an example. But one thing of interest, when I first started putting this together, there was this organization called the Rocky Flat Stewardship Council. And that was an effort funded partly by DOE and local governments around Rocky Flats so that they could retain the information and communicate to future generations. Well, unfortunately, they just shut down, so they no longer exist. So that didn't work, looks like. There was a private organization formed by this brilliant lawyer at the Industrialplex 128 site north of Boston, where the Woburn site is. And if you haven't read it, there's a book called The Civil Action and a movie about the site. But she created this long-term stewardship trust program to ensure there's funding and technical capabilities to maintain the sites indefinitely. And now she's offered it a service to do that same work elsewhere. And this is the contractor that DOE uses for legacy management that is offering that capability to other sites as well. The question is, how do you institutionalize these things? And I would just suggest three specific things that the government could be doing. One is actually create a central organization that combines some of the lessons learned from DOE, EPA's 5-year reviews, from some of the private sector organizations. And it may be a single organization, it may be individual organizations within states that are implementing the so-called Uniform Environmental Covenant Act requirements that provides a state police power to enforce institutional controls and do it state by state and have a coalition of these organizations that trades notes. But somebody's got to actually do this. Somebody's got to go into the office every day, pour themselves a cup of coffee, and start working on long-term stewardship of all those 6 things we talked about. Or it may be 6 different organizations, I'm not sure. But to create organizations, and the government could actually have a role in doing that. Secondly, to have some way of ensuring that there's durable funding. As many of you know, we have something called the Anti-Deficiency Act, and that prohibits a federal employee from expending money that hasn't been appropriated, and appropriations are on an annual basis, 1 year at a time. Now, at the Oak Ridge site, we have a trust fund that provides funding for long-term stewardship of the new landfills down there. And maybe similar trust funds could be set up at other sites as they've done at Oak Ridge to deal with that, the Anti-Deficiency Act obligation to only spend money 1 year at a time, when we know that the requirement is going to last for many years in the future. And thirdly, establish some sort of information repository. And I might even suggest that you look at the Library of Congress as a way of consolidating all that information, maybe the National Archives. Problem with the National Archives is they're dependent on individual agency funding and preferences. And sometimes agencies don't want to have that information out publicly. And there's sometimes a sense within the Department of Energy that doesn't want to advertise the fact that after we spend $1 trillion, you're going to end up with about 500 sites that require long-term stewardship. And that's not something they like to advertise and circulate information about. So that's perhaps a role for Hanford Challenge or other watchdog groups to make sure that information is out there for future generations to have and to have access to it. But it may be a whole separate repository of information. So some of the states haven't instituted these things, these uniform environmental covenants, and maybe that's something we could do more of. The Long From Now Foundation has looked at the information retention, how to communicate it. In other countries, they actually put the waste right into something that they think will last longer, that has already lasted in an art museum. So in the Netherlands, some of the storage for art museums, or actually in an art museum with some of these tapestries, they put some of their low-level waste. So they bring school groups in regularly. And so that's a way of passing on to future generation where the waste is and what hazards it might pose. In one case, there's a building with paint that fades over time with the Netherlands where they store the waste. And it's a pretty substantial facility there. This is not a minor operation. And the idea is that in 100 years or so, this is for low-level waste, it would fade from orange to white, showing that it's decayed. But as long as there's any color in it, it shows roughly the degree of hazard posed by it. Whether this works or not, but there's a lot of ideas out there that people are dealing with. Um, the French have a system where they're putting their intermediate level waste, the stuff that we put into shallow burial, they have devoted to deeper disposal. And the Japanese have done a similar thing with what we would call low level or intermediate level waste. And kind of fundamentally, as I mentioned, there's a distinction in the way we define different types of waste. We define waste from where it came from, not how much radioactivity is in it. Um, and the big challenge is you've got a site where people are concerned around Rocky Flats, and it is a challenge with institutions where people don't necessarily believe the government anymore, whether there is a risk or not, and how to pass it on to future generations when there is a site there. So just to wrap up, uh, maybe the long-term idea is a real simple one. Long-term stewardship is what you do at the end of the pipeline after you've done the cleanup. The solution may be that before you actually start producing a product like nuclear warheads or do a service, you actually have to think about where the waste is going to go and how you're going to deal with the waste products so you avoid the contamination in the waste products as much as possible. It doesn't mean that we don't produce any warheads, though some people might think that's a good idea. It doesn't mean you don't make any more cars or airplanes. It just means you think about it in advance. That's all. And you continually evaluate it over the long run. Um, the Vatican Library is maybe one example where we've stored information over the long run. And in fact, there is a copy of some of the Department of Energy documentation about contamination there now. I guess I would leave you with this thought. I mean, I was somebody who just crawled under a fence, but one of the experiences I had early on was, when Tom Grumley was first starting as assistant secretary, and he had enormous experience with hazardous waste sites, but very little on radioactive waste. There was another industrial accident out at Hanford where a worker named Lou Beatty was burned severely when a steam valve burst, and over 50% of his body was burned, and he ended up in the hospital. And Tom came to me about it and wondered if it was worth going out there to see him in a hospital, to express concern and to try to emphasize again occupational safety and health for workers at the site. And so I can't remember exactly what I advised him about the trip, and because it was sort of at the end of a week, it was June 7th, and he had a lot of other stuff to do, but he ended up flying out there. And part of my job supporting him was we gathered a bunch of information, and the official documents that I got from the DOE offices, both program and ops office, were that workers at Hanford were exaggerating their exposures, and it really wasn't that big a deal, and that we have to take that with a grain of salt. And they sent documents to that effect. And my advice to Tom was, Tom, there's been a history of industrial problems and accidents at Hanford, and there's a number of whistleblowers who have come forward to register their concerns. The same whistleblowers that Hanford Challenges represents and protects every day. So Tom went out there. He saw him in a hospital. He was in pretty bad shape. And again, the DOE word was he's going to recover. There's just a history of workers at Hanford exaggerating illnesses. So he flew back over the weekend, or by the end of the week. By Monday, Lou Beatty had died. And I guess the point is to keep in mind the individuals, whether it's a kid crawling under the fence or the workers who might be exposed at these sites. That's the point of trying to have a robust long-term stewardship program. We don't have one now, and it's up to all of us to figure out how we're going to put that together. So thank you very much, and I'm happy to take questions.
Thank you so much, Jim. I so appreciate all of that you've shared with us today of lived experience, institutional knowledge, and then the research you've done with the Library of Congress on this topic. It's just fantastic. So thank you.
Well, Mia, I'm going to be dead soon, so you got to take over. I mean, I'm feeling okay this afternoon, but
I'll try.
okay.
I've seen questions coming through. Please put any questions that you've been holding back in the chat or the Q&A feature in Zoom, and I can start reading those off.
Okay.
There was a comment on the sign for Coldwater Creek, the new signs that we're putting
Yeah.
up, that it didn't include a trefoil as a symbol on the sign. And the person was wondering about the rationale behind that.
Oh my gosh. I can give you the quick answer or the more detailed answer. So the news media has called that a radioactive waste site. Some of us waste nerds might more precisely say that it's 11E2 byproduct material. And so the trefoil is generally used for irradiated material or fission products, not naturally occurring radioactivity. It's not exactly norm, it's 11E2 byproduct material. So um, sorry for the nerd answer, but you ask a wine steward about what wine you want, you're going to get a longer answer about whites and reds and dry and sweet. You ask a waste person about different types of radioactive waste, and it's actually not technically a waste. So I generally don't raise that point with people because they roll their eyes and say, well, it looks like waste to me. It's not byproduct material. Because actually the material that came from that was not directly derived from the active isolation and refinement of the uranium. It came from what's called the Cotter chemical concentrates of subsequent refining by a private sector company that tried to commercialize it and dump it out as a byproduct material. So that's why it was allowed to be used for daily cover at Westlake landfill.
Okay. Okay. Thank you. Um, we have other questions related to the St. Louis contamination. Um,
Ah,
and
which St. Louis? There's so many sites around St. Louis. Which one?
it's not specific.
Okay.
We're concerned on how the EPA handled the St. Louis contamination. The EPA focused on the buried Manhattan site and not on the source of the contamination, of which the community had been contaminated with. Transparency is out, or is our concern, and not trying to dance around the local community caught up in the real contamination sources. Um, for some contamination sites, we have been the only source of exposing the community, I believe, has been the only source of exposing the disinformation and misinformation. Another, can we add sites with our data in your own government data with safety issues addressed? I don't know if that's something you can answer.
That sounds like a much longer discussion, but I've
Yeah.
heard those concerns. There are a variety of sites around there. Um, and one of the studies that I did, that we publicized a lot in the early 90s, and I'm sorry if they didn't get that information at that time, was the so-called VCs, or VCPs, the vicinity property sites. And goodness gracious, there was radioactively contaminated material we surveyed that was along the sides of the streets, in cornfields, in a baseball dugout. Um, actually, if anybody's into monster trucks, Bigfoot is there in a garage, and there was contamination right near there. Frankly, the Department of Energy had a contract that it was not performing. That was one of the reasons that the whole operation was shifted over from DOE under the FUSRAP program to the Corps of Engineers. But and that's part of the challenge is that every generation you have a new group of people discovering it and not aware of all the information, all the publicity. So with regard to EPA, and this maybe get into the bureaucracy too much, because of the unitary executive theory, the federal US EPA has a limited authority for overseeing the activities regarding another facility, notwithstanding the Section 120 of Superfund. It really comes to the state to use its standards in what's called an interagency agreement. And because there's a record of decision at that site, there's been a number of efforts, including while I was there serving as a state environmental director, to conduct what's known as an explanation of significant differences, or an ESD. So after you have a record of decision, you have to come up with new data essentially to sign an ESD to determine that some additional remediation or a different construct is required. And so far as I know, there's been no ESD there based on new information demonstrating exposures. Be happy to talk to the person offline if they're interested in this, but I have, I guess that I've talked to certainly a lot of people around Wilton Spring. I've not been contacted by the people who I know are now interested in the site, particularly around Westlake. But those vicinity properties, uh, don't get me started. It still bugs me.
Yeah.
You can tell.
Thank you. Um, we have, so did you ever investigate the early uranium mining in Western Colorado before 1935 along some San Miguel River towns? Then they covered it all up.
I did not, and it sounds like an interesting area. So I just have made a note of it while you were talking. So I'm curious about
Okay.
that.
Another question
Let
is,
me just say that the United States undertook an extraordinary effort to find every place it possibly could to produce uranium. And there's many, many anecdotes, but if you look, I think it's available on YouTube. Actually, there was an I Love Lucy episode about uranium mining in Colorado and New Mexico and Arizona, just kind of illustrating how this kind of penetrated the popular news media. But you know, the the original uranium came from pitch blende that was from a mine in Czechoslovakia, and some of the mines and some of the work, like the El Dorado refinery in Port Hope in Canada, were originally for other minerals, and then later converted when they realized, hey, uranium could be valuable too. So I've not heard about this one on the San Miguel River. So thank you for educating me.
yeah, yeah. Okay, we have, what do you think about the NRC not considering climate change issues in environmental reviews for permitting?
Well, that I'm going to take as somewhat of a rhetorical question. We could fill the next week with discussions about climate change. I mean, there is almost no end to how climate change will affect our lives, our economy, our natural landscape, our transportation, our food systems, our water security. And of course, Sherry Wasserman's Goodman's book points out our national security affected by climate change. And um, so if people haven't seen that book, it's called Force Multiplier, and she just published it. And certainly, all of these sites where, again, we thought we were done, and I had that nifty little cycle. You're not quite done because stuff happens that we weren't expecting. As Mel Brooks would say, nobody expected a Spanish Inquisition, and suddenly, you've got that to deal with.
Okay, related to the Project 2025 and how Hanford is in it, um, how do we cope with the new administration related to Project 2025 and Hanford, but also with the passage of HR 9495 Act, the Stop Terror Financing and Tax Penalties on American Hostages Act, that can allow U.S. Treasury Secretary to target 501(c)(3)s that the Trump administration could disagree
I don't have an answer to that. I would just say together, and I'll put in another pitch for Hanford Challenge. Unfortunately, Hanford Challenge has always done good work, and your good work is becoming even more important because the number of groups involved in this has shrunk some. The good news is there are a number of young people coming into this, and that is so important to have new people coming in to work on it with fresh energy, with fresh ideas, with fresh perspective and fresh training, because it's a long road. This stuff will outlast all of us. Um, so I do, and I think of Lydia Popova in Russia, who worked for years at Minitom and then formed Sociological Union. And she unfortunately passed away way too young. But she has a son who is involved in energy activism in Russia. And if they can do it and have the kind of courage that they had. We can.
Yeah, yeah. Thank you. What do you think about DOE's webinar roadshow for selling interim consent-based siting of waste to rural areas, maybe with a small modular nuclear reactor thrown in?
Such a deal. No. So what do I think of it? And again, that's a longer commentary. I appreciate your highlighting that. Just for those who aren't familiar with it, the consent-based citing arose from the decision to finally throw in a towel on the Yucca Mountain repository in 2009, 2010 that resulted in what's called the Blue Ribbon Commission that produce really a series of reports. People should not think of that as a report because there's subcommittees each put out a report. But one of the take-home lessons was that you can't just force this down people's throats, that people have a fundamental right and an ability to control things that will affect them and to have a right in participating in that. And that's not going to change no matter what wishful thinking you might have. And so that is very consistent with what the Obama administration set forth in its Blue Ribbon Commission. Now, whether SMRs happen or not, goodness, I don't want to get too much into nuclear power.
Yeah,
Um,
that's
I will
fine.
just say that, while I got trained as an engineer, my dad was an artist. And one of the things he made his money at was doing artist conceptions of things that didn't exist for like Boeing or, whoever would pay to have an artist conception. So you draw something that doesn't exist and then they make it look very realistic. Um, so that people will buy into it. And, that's what put food on our table. And so, when I look at all these proposals for small modular reactors, I think of all the families who are supported by an artist who does these artist conceptions. Because as far as I can see, that's the biggest product coming from it is artist conceptions of small modular reactors. And we've had small modular reactors. We had SMRs in the Army in Fort Wainwright and in Virginia. Every naval submarine reactor is a small modular reactor. It's just a very expensive way when you're using a nuclear reactor to unleash the fundamental forces of the universe to boil water. It's just an expensive way to push electrons.
Yeah, thank you. Um, um, I am concerned about, oh, this is related also to nuclear energy, so maybe we won't. Um, has the increased oil and gas wells surrounding the WIPP site increased seismic activity due to injected produced water from the drilling activity?
I do not think so. I don't have any specific information on that, but I know who does. Don Hancock with the Southwest Research Information Center is an extraordinary resource for all things WIP. And I think if you looked at Don Hancock's material on the SRIC, Southwest Research Information Center in Albuquerque, they would probably lead you in the right direction. But as far as I know, it has not.
Yeah, thank you. Thank you so
You're,
much.
wel- you're welcome, Mia. I hope this
Yeah.
has been useful to you all and adds a good contribution to the great work that Hanford Challenge has done.
Yeah, absolutely. Thank you, Jim. And thank you all for attending.